Hi, good morning, good afternoon. Thank you all for joining us today on this webinar, Real-Time Data 360 for Apache Spark. Thank you very much for joining us today once again. We are today with our expert panel and speakers, Anand Venugopal and Puneet Shah. Anand is the product head for StreamAnalytix, which is an open source powered enterprise-grade streaming analytics platform developed by Impetus Technologies. Anand has 20 years of software innovation and business development experience in the enterprise and the telco space, and is specifically passionate about solutions based on open source technology stacks. Our second speaker is Puneet Shah. He has been a key member in building enterprise-grade applications and platforms running hundreds of millions of dollars in revenue for Impetus customers. He is the lead architect for the StreamAnalytix product and part of the original technology team that created StreamAnalytix that we just mentioned. He's also working on many large enterprise engagements to help them build a variety of streaming and complex event processing use cases. Now, without further delay, let me invite our first speaker for today, Anand Venugopal. Anand, over to you.
Thank you very much, Pankaj, and welcome to our audience. This is Anand Venugopal. I've been with Impetus since January 2010, and I'm leading the StreamAnalytix product business. Many of you probably have engaged with our webinars before, so it's a pleasure to be with you again if you're a second timer on our webinars. And if you're listening to the recording as well, welcome. So we are here to speak to you about a concept called Real-Time Data 360 on Apache Spark. Without further ado, let me go right into what, how we're going to spend our time. So intro and context setting and the Data 360 core concept itself, we'll be spending about 15 to 20 minutes. And then we're actually going to be showing a demo of what we are talking about so that it's not just a concept, it's really live in front of you. So, and then we'll, of course, do a full-fledged Q&A and where we encourage you to fully participate. So some guiding principles for the webinar here that we want to share. We're not quoting any, survey results and showing you fancy charts, etc. today because we're really sharing our own direct experience with 50 to 100 enterprise engagements that we've had in terms of early stage conversations, advanced stage conversations, and actual production rollouts as well. POCs, etc. So we're really sharing with you the knowledge we have and our recommendations, our suggestions for how you could do what we call Data 360, which I will elaborate very soon. So, and whatever we share, we're not really righteous about it. We're not attached to our view. There's no right or wrong way. There's obviously consequences for whatever pathway we choose, and that's why we're just sharing with you some thoughts around this. So, and whether you agree or disagree, it's fine. Please share your thoughts. We respect your thoughts and your experiences and your feedback. So whenever we do a poll, etc., later in the webinar or any time during the webinar, if you want to send us inputs, please do. So let me begin with where you are today, which is, and most of you here today are representing the enterprise data technology landscape, and some of you may be representing the line of business. But you're overall in charge of making things happen in the enterprise. So where we see enterprises today is that the enterprise data technology landscape is dramatically changing. People are very familiar with these things called Lambda and Kappa architectures. Earlier it used to be that we were educating the enterprise stakeholders, and now what we see more and more is enterprise stakeholders coming to us and saying, look, I want to implement Lambda, I want to implement Kappa. And so there's definitely a way ahead of where we were compared to 2 or 3 years, 4 or 5 years ago. And the key drivers are that most of you are, having a big data lake project in the program. You've already purchased a big data platform, either on-prem or on the cloud or both, and that is becoming a default. And then what is becoming additional to the architecture is IoT and streaming analytics. And most of you are also considering machine learning and artificial intelligence at an early stage in many use cases. And on the consumption of the data and insight side, we see a lot of demand for self-service, low latency, slice and dice on the consumption side of the data as well as the insights and the BI. So we are also seeing a hybrid, usage of both legacy systems and big data platforms, and slowly that might end up becoming, a 100% big data, but right now it's hybrid. And most large enterprises have just got started with the replatforming exercise, and it is obviously a multi-year program. And that's the kind of audience, or this is the kind of assumption about the audience and the situation that you are in that we are making today. And it's an assumption as well as as an assertion, because we are representing some of you and where you are as well, based on our experiences with you. So now that's where the enterprise landscape is. Now let's look at what the business is saying, right? Most business stakeholders have already heard enough about this whole hype of big data analytics. They've been to their own conferences, they're talking to their peers, they're coming to enterprise technology stakeholders with demands for the fruits of big data. They're saying, look, where are my integrated data silos? Where's my single source of truth? They want it now. They want the promise of big data fulfilled. And the ubiquity and fast access to data is another thing that people are looking at and again demanding. So the other part of what big data analytics use cases in terms of demands from the business are, hey, give me actual big data enabled use cases. There are some of these use cases that are being deployed on legacy systems, but there is now a demand for actually doing big data enabled use cases, including customer 360, predictive maintenance on the manufacturing side, churn, fraud, personalized recommendation, upsell, cross-sell engines. Security, of course, is one of the biggest apps in big data, and people really looking for real-time dashboards for everything. So now we got the technology landscape overview, we got the business demands. Now, what does this mean to you in terms of specifically what needs to be done on the data side? So these demands imply that you have the following data challenges shown in this slide, where you've already, first of all, you've got to establish your big data lake. Whatever technology you're using, it could be Hadoop, it could be a NoSQL type environment, then it could be a hybrid of cloud and on-prem, like I said before. But then starting from there, you have these next level tasks that you have to complete. And I think the low-hanging fruit that a lot of vendors are latching onto is ingest, and it's naturally so, because the first actual active task that you need to do is ingest data into the data lake or into an in-memory cluster for real-time analytics. So both batch and streaming ingest from a variety of different sources, using message queues like Kafka or other custom mechanisms, or directly reading from databases doing CDC, change data capture in, or from file systems, or from REST APIs. From various different sources, you're trying to ingest data, and that's the biggest challenge. And so there are vendors that are just solving that, and we'll come to the whole vendor ecosystem and the problems with that as well very soon. The next aspect is, you got all of this data, especially with IoT, you've got a lot of streaming data coming from sensors. There's the data quality challenge as well. You cannot subject data to analytics without examining the data in terms of its quality and ensuring that it's ready for analytics. And in that process, you might end up doing some cleansing, doing transformations on it, and there's also a need to transform and blend data from different sources. So it could be a streaming source coming in, or a number of streaming sources coming in. It'll probably have some metadata, some indexing keys that you need to use and pick up data from a static data store. Take let's say a set-top box ID is coming through, and you're matching the set-top box ID with a customer ID, reading from the customer table, blending it, and creating a composite record for downstream analytics. So that kind of blending among streaming sources, among streaming and batch sources, and enrichment. Enrichment meaning once you blend it, then you're further enriching it to add location information and things like that. So that's what we mean by the blending and enrichment. And then, of course, we subject the data to analytics, which is the statistical analytics, rules-based, or it could be predictive analytics with your machine learning libraries. It could be prescriptive analytics as well. So a variety of different analytical tasks being executed on the data using a variety of different tools. That's what you probably are looking at. And finally, we have the loading and visualization. When we say loading, and we position loading deliberately after analytics, because in the modern context of in-memory clusters and distributed in-memory programming paradigm, you don't need to load the data anywhere before analyzing it. You can analyze it right in memory using, let's say, Spark or other technologies like that. So that's why we're not implying that you're loading up front, as in the earlier paradigm of ETL, where you transform and load, and then you pick it up again and analyze it. So loading takes place either upfront or later, whatever you can do in terms of arbitrary data flows. And the challenge there is targeting various target data stores, including HBase, Hive, HDFS, or other stores like MongoDB or Cassandra, or just regular RDBMS, including SQL Server. So you might have to load in multiple data targets for various applications to consume. And very often your Hadoop distribution or your cloud vendor may or may not provide you all of those connectors. You end up having to build out some of those connectors, both on the ingest side as well as the egress side. You have to then also secure data access for self-service mechanisms. And especially when you have a lot of people accessing a lot of data, when you have privacy issues, when you have sensitive data, you've got to provide a full governance framework to really have enterprise-grade big data analytics exposed to various stakeholders. So that's what is the range of challenges you're looking at as enterprise data stakeholders. Let's go deeper into what we are subsetting as what we call data360. So let me go one slide back. I think I skipped. So when it comes to streaming data, things get even more interesting because data is coming in always on. Your system is always on. Your pipeline is always on. It's high velocity, high volume streaming data coming in. Imagine doing data quality checks at that speed, at that volume, doing transformations, blending, enrichment. So you're obviously talking about a different grade of technologies than clearly from the legacy regular batch-based systems. So we are calling the subset that you see on this screen here from ingest to visualization as data360. And naturally, we're just borrowing from the whole customer 360 paradigm where we're talking about customer data across different channels. We're not talking about customer 360 here. We're talking about data 360, where we're just simply aggregating all of these active data tasks into a set of a logical paradigm called data 360. So and these, why we're aggregating these are because these are the active data movement, data manipulation, data computation tasks that we undertake with an active computational system, may it be your proprietary products or open source products like Spark or Hadoop MapReduce or Storm or other engines like Flink, etc. So these are the active tasks that you would have to do on Spark on the data itself, and that's what we're calling data 360. So you've got all of these challenges to solve, and then you look out at your vendor ecosystem, right? And you open the curtain outside and see your vendor ecosystem, and there you see a whole bunch of friendly big data ecosystem vendors out there staring at you, knocking on your door and saying, hey, my product is the best, choose my product, it will solve all your problems. There lies the problem, right? And by the way, me and my colleagues are part of this team that's knocking on your door, offering our solutions and our pitch to you, I'm sure. When you look deeper into this, the problem with this ecosystem is that you got many suitors for each task, but none for all. So you got ingest vendors that are specializing in ingest, but may not be doing analytics all that well. There's the yesteryear ETL vendors that are doing, that have transformed their products from a legacy paradigm to a big data paradigm, or at least maybe in the process of transforming, maybe a little bit half-baked. Now, they are specialized in ETL, DQ, DI, and loading. There are some new generation vendors that are wrangling vendors. Of course, there's analytics and machine learning. There's visualization. You're kind of stuck with the default predictable pathway of having a multi-vendor situation where each vendor is specializing in their piece and not really doing the whole thing. That's a difficult scenario because the more vendors you have in the mix, the more products and technologies you have in the mix, the more probability of failure and complexity. So you're looking, when you start doing your POCs, and I'm sure many of you on the phone are doing a lot of very active POCs, and you've done implementation as well, not just POCs, you'll find that these vendor ecosystem, the products are incomplete from an overall big picture point of view. There are still gaps in the ecosystem that you have to fill yourself with manual coding, etc. You find that some of these technologies are incompatible. You know, some vendors are aligned with each other, some are not. And you know, with your Hadoop distribution that you picked, you may find vendor X, which is good for another siloed functionality, which is not compatible with your Hadoop distribution or cloud vendor. So there's inconveniences for you as an enterprise stakeholder, as an enterprise data architect, putting together the enterprise-grade big data analytics platform. So overall, the situation could even be intimidating sometimes with an incumbent vendor that's connected to all the big shots in the enterprise, you know, saying, you know, pick my product, you know it's the best, etc. We've seen that situation also a lot. So it's an overall integration nightmare. It's an inconvenient situation. We don't mean to be really, you know, overhyping the negative aspect of this. It is inconvenient and to different grades depending on how competent your team is and how well things are organized. But overall, we're saying it's a less than desirable situation because the probability of failure and delays, like I said, you know, dramatically increases with the more vendors and products in the mix. So you're thinking to yourself, geez, is this really what I signed up for? Wasn't big data supposed to solve my problems? So we understand. We empathize with you. That's why we're trying to share a different view here. So let me just, you know, pause there and ask you, what do you want? The good news first or the bad news first? Rhetorical question because the webinar, you can't speak back. I'm just going to pause. I'm going to move forward with that. The bad news is that you really can't eliminate the multi-vendor situation. This ecosystem is broad, and the task on hand is big and complex. But let's see if we can minimize that picture, right? At a minimum, we think that you need a Hadoop on-prem Hadoop vendor and or cloud vendor and a mix of those two in some cases. You need a system integrator or your own fairly big IT team to really get a hold of all of these moving parts and put an enterprise-grade system that can satisfy and keep users happy. You need, in some cases, niche products like security, governance, and virtualization, which typically may not be done extremely well by your Hadoop distribution vendor, or we've seen often in our experience that, you know, people do use specialized vendors in these cases. Now, the good news is, you know, so the whole spirit is to try and keep it down to a minimal set of vendors, right? The good news is, for the core data processing aspect of what we talked about, which is data360, you got Apache Spark, which is thankfully part of your Hadoop distribution or your cloud vendor that you already signed up for, right? So let's stick with on-prem to be simple, to be less complex. On the on-prem side, on your Hadoop distribution, you already have Apache Spark, whether it's MapR, Hortonworks, or Cloudera. They all package Apache Spark with it. And you're probably on to, you know, 2.0. Many people are on to 2.0, and some people may still be with 1.6. Whatever it is, Apache Spark enables you to do the full data360 spectrum of ingest, cleanse, transform, blend, analyze, load, and visualize all by itself. And we're going to show you a little bit more about that. But and 60 to 80% of enterprises have already adopted this. So going further on that journey, there are APIs directly on Apache Spark that map to all of these stuff. You know, we just listed a few here in this table here, and very soon you'll also see that we have organized our product and what we're going to show you in terms of a demo along these lines. We feel that there is a robust set of functionality provided for each of these pieces or each of these phases on Spark, and if we have a UI-based approach to all of this, it might be even better. So let me come to that as well. So when you're thinking, hey, all of this is great, where do we find the Apache Spark talent for the Java, Scala programming, the Python programming potentially that can do all of this work. Are you telling me all of this is manual and I can get all of this done manually? That's a typo right there. It's enterprise grade. Sorry for the title, the typo in that title there. It's enterprise grade hand-coded Apache Spark. It's obviously a sarcastic question there because it's really hard to do enterprise grade hand-coded Apache Spark because it's a different programming model. Your existing enterprise developers can't simply just come in overnight and start becoming productive. You're not just talking about a hello world program and doing a functional equivalence. You're talking about really building a scalable platform with scalable applications. And the monitoring, the DevOps, the challenges can be pretty intense because when you have an application at scale, you're talking about debugging and diagnostics at scale. You have to do version management of Spark pipelines where developers building version 1 and then you've got to track a difference between version 1, version 2, version 3, and maybe roll back, etc., as needed. You're talking about a convenient way to promote from dev to test to production in terms of all the non-functional aspects I'm referring to now. And fundamentally, you need a multi-tenancy system where your developers or your teams are using a common infrastructure in a multi-tenant mode where they can all use shared resources, even in on-prem, even if you don't go cloud. You got to have a multi-tenancy system with different permissions and different role-based access governed to all the tenants. So bottom line, you really do not have a strategy that scales with manual Apache Spark coding. It's very hard to do that unless you have an army of extremely smart Spark developers, which is unlikely, which is rare in our experience. What then is the solution to this, right? The ideal solution, we say, would be probably a business user-friendly, a developer, data science, and business user-friendly user abstractions on Apache Spark, and you take care of the enterprise-grade functionality on it so that you can do all of this with ease, with simplicity, and also the enterprise-grade non-functional aspects are handled. So NetNet, we're saying a better approach for data360 is a visual Spark approach with the Visual Spark Studio with a drag and drop kind of interface, implementing the real-time data360 tasks. And when we say real-time, it includes batch processing tasks, where Spark Streaming and Spark Batch APIs are drag and drop widgets, and you have different abstraction layers based on the user competency level, which is the developer level, data science level, business level. So this is not just theory, this is not just a dream, it is realizable. We have realized it with our StreamAnalytix product, which we'll show you. It's not intended to be really a sales pitch, but more of an example and illustration. So over to Puneet for a demo here of our platform. We'll show you, walk through the data360 done with StreamAnalytix, and we're doing a batch use case first, and then we'll also show real-time streaming analytics and both pipelines, how we build out data360 with Spark.
Right. Thank you, Anand. You all will be able to see my screen now. What you see on my screen is a view, one of the views of StreamAnalytix platform. In this demonstration, I shall show how we can realize different kinds of use cases on StreamAnalytix, specifically in the vision of data360 and Visual Spark. One of the use cases I'm going to speak about is an industrial IoT use case that we have done. Out here on the screen, what we see is different tiles. Every tile represents a Spark streaming or a Spark batch job that has been created in a visual fashion on the platform. One of the use cases, industrial IoT, that we shall look into. I'm clicking on the edit mode to get into the pipeline that was built. What you see on the screen here is the entire visual representation of the industrial IoT use case created on Spark in a visual fashion. The use case was batch in nature. What we see on the extreme left are two different data sources that came in as part of the data sets. One was coming in as files landing inside of HDFS, and the other source was data coming inside of Oracle database in the form of records in a table called IoT details. The use case itself had two different sources, one being plant meta information and the other being attributes at plant level. Those two data sources were read, joined, or blend. As part of data360, the very first step is getting the data, that's ingest, happening on this level here. Next stage, blend and data quality and transformation, which we did using various different out-of-the-box operators. I shall go through the operators list very shortly. Once the data quality check and the transformation, etc., has been done on top of the incoming data, next is doing any kind of analytics, rule-based, statistical, machine learning, depending on what the use case is. In this particular case, we are trying to do statistical analysis where we need to find out the histogram distribution of the IoT data, namely temperature, pressure, humidity that's coming in. Next, we want to calculate standard deviation for these operators or these attributes. Thirdly, doing aggregation, computing average value for all of these operators for that entire batch record data set that we get for a particular business unit. So all of this, again, as you see, can be done in a visual manner on UI without really writing any code. Simply drag dropping operators and configuring them. Next was alerts. In case if the standard deviation for any of the incoming attributes that have been calculated goes beyond a certain threshold, we want to raise an alert, hence the alert operator. Lastly, the geopoint enrichment, which leads to the enrichment stage in the data360. Once the data comes in, more often we have seen that the incoming data is not sufficient enough. We need to typically enrich the data by making lookups to external sources. We have an enrichment operator which allows us to do this in a very easy fashion. Example here is a lookup edge base where we are making a call to the edge base table called plant geolocation, wherein based on the plant ID or the business unit ID that we get as one of the input attributes, we make a call to edge base table, we fetch the lat long values, the latitude longitude values of that plant and embed or enrich that into this data so that later on this data can be more normalized and persisted into the data lake system. There are additional such attributes and functions that can be used. For instance, if I do a $sign, you see all these different functions in the platform. These functions range from string manipulation, object manipulation, date manipulation, and even lookups. So all these different kinds of functions can be invoked on the incoming data. Additional new functions can also be written and registered. Lastly, going ahead and persisting the data or the final output into one or more data sinks. In this particular case, we had to write some of the information into Elasticsearch and the rest of the information into HDFS file system. So all the various stages of data360, that is ingest, blend, transform, data quality, analytics, enrichment, and load can be realized in a very easy visual drag drop fashion. From a visualization perspective, we have more often seen two different kinds of visualization strategies. One is out-of-the-box reporting for real-time streaming data using real-time dashboards kind of a concept. We have a real-time dashboard itself in StreamAnalytix, which I'll be showcasing further in the demo. And the second kind of visualization is more based on reporting tools like Tableau or even custom visualizations. For this particular use case, we had a custom visualization built in. Let me quickly open up the custom visualization. So as part of this custom visualization, we saw the data coming in. As you recollect from the pipeline itself, we saw latitude and longitude being enriched into the incoming data via the lookup edge base function. Once we had the lat and long, we had to plot those on a geo map, just like we see here. We plotted the business units on the geo map. On the top right, we see alerts. So if there were any alerts, this would have been having a counter next to it if there were any unread alerts. Clicking on that shows us all the alerts that were historically generated for any of the particular business units. I can also click on any individual business unit to get more information about the business unit itself. What was the temperature, average temperature computed for that particular file? What was the average pressure and humidity computed, the standard deviation for those attributes, and similarly the histogram that was computed for that batch data set. So all of this computed was persisted into Elasticsearch and HDFS, and this custom visualization has been built on top of these two data stores by querying them and fetching the records and showing it on the UI. Let me move to the real-time dashboard visualization. What we have here is the inbuilt feature of the platform where I can create multiple widgets, and streaming data as it comes in on Spark can be visualized on the UI without really being required to be written onto a disk. So I can simply go ahead and start visualizing my data. Just like any standard visualization tool, this dashboard has capabilities of adding, creating new widgets, changing the layouts, drag dropping different widgets, all of that, and simply saving it, distributing it with other users within the business unit. I could do any of that as well. Coming back to the data pipeline view, very quickly walking through various different set of operators that we have. So what we see here is application type as batch or streaming, depending on what needs you have. Is it a streaming use case or a batch use case? You can pick up appropriate application type, and based on that, you will see different operators here. Channels fall into the ingest bucket of data360 vision, where on the top you see more high-level operators which connect to data sources like Twitter, like Clickstream, Adobe Omniture, Marketo, Salesforce, and so forth. And as part of the advanced data sources, you see more technical-oriented data sources like connecting to Kafka, MQTT, JMS, file systems, etc. Next, in data360 stage, we more than often see transformation, ETL kind of functionalities. We can do all of those again using the easy, simpler to use data operators or even the advanced ones. The advanced ones will map more frequently to the underlying Spark APIs, as some of you are already familiar with the Spark platform will realize. The third category is analytics. Spark machine learning algorithms that are available are all again available on the platform to drag drop visually on the canvas, configure, and then start using them. Certain set of algorithms amongst these like regression, k-means can also be used for real-time learning. And lastly, the emitters, which allow you to write the data into one or more sinks. For instance, writing into Kafka for some downstream system to consume, or even writing into HDFS, Edgebase, Cassandra, or indexing stores like Elasticsearch and Solr. So all of this is great in terms of building a real-time or a batch data360 kind of a pipeline. But then the next question that comes in is, wow, you built this, you deployed this on a cluster, but also monitoring aspects and lineage and auditing aspects become important. And from that perspective also, certain things that we kept in mind was the ability to version the pipelines as you keep making edits to that. Subsequently, also going ahead and doing some kind of lineage view or auditing. So I'm just going to go to the lineage view very quickly. I'm going to search for one of the records which has already been streamed. So what we see on the screen here is a complete lineage view for that particular record at a particular timestamp which had flown through the entire pipeline. The path that that record took in the pipeline is all demonstrated via the green lines. I can click on any of these operators and start seeing what the payload was as it entered into the pipeline. As I keep moving through different operators, I see the payload keeps changing. That's because as the event progressed through the pipeline, it underwent changes, it underwent all the business transformations, data quality checks, and all those can now be very easily visualized, monitored, and even audited. For debug purposes, if sometimes historically you need to see what had happened for a particular event, why the risk assessment score, for example, was scored high, what was the reason, you could come to the lineage view, search for it, and look at all the attributes that led to that particular score being very high. So all that kind of debugging is also possible. Very quickly, I'll move on to one of the other pipelines, a network anomaly detection pipeline, to demonstrate how streaming use cases can also be built onto the platform using machine learning algorithms. Sorry. What we see here is two different sources, training source and prediction source. Both these sources are reading data from Kafka and landing into a streaming k-means algorithm. As I mentioned previously, the streaming k-means algorithm has the capability of doing real-time learning, hence training source as one of the inputs. Let me just open up the k-means algorithm, and you'll see all these different kinds of configurations that have been done. If you are a data scientist and you're comfortable providing all these configurations on the UI, you could do that. Alternatively, if you have created your entire model definition somewhere else, you can simply come in, upload this, and all of this configuration can be done right here on the UI just by simply uploading your predefined model that you built somewhere else like R or even notebooks like Zeppelin or Jupyter. With that, I'll quickly wrap up my demo. Over to you, Anand.
Great. Thank you very much, Puneet, for that demo. We're really interested to get feedback from you all today. You saw some. We're going to get into the Q&A a little later in a few minutes from now, but we want to get a sense of from your side, do you agree that Apache Spark is a great place to begin a one-stop shop for real-time data 360, as defined here in this webinar? And you see the poll showing up for you on the bottom right of your panel. So click on A or B, or yes or no for both of these questions. And would you be interested in a deeper dive of real-time data 360 with StreamAnalytix? This is not really intended to be a sales demo of any kind, although some of you might perceive it like that. The intention is to show you what's possible with Spark and how Apache Spark is a great candidate for bringing together all of these functionality on one platform and bring the entire journey of ingest to visualization from one single UI screen that a developer and business analyst can get together and orchestrate the entire data flow. So please answer these questions, and we will close the poll in a few seconds, and we'll get to answer some of your questions as well. We've already started answering some of your questions directly, and we'll answer more of your questions as well. Thank you. So the poll has ended. Let's do a quick recap before we get to the questions here. So what we're saying here in this webinar today is that real-time data 360 with Apache Spark is possible. Otherwise, you would have a lot of point solution vendors integrated. If you're trying to replicate what is already possible with Apache Spark with different vendors, it becomes a multi-vendor mess. Now, a lot of the vendor ecosystem are very, very smart, great products. You get ready-made functionality, so the build versus buy works. But we're saying that there's a lot you can build easily and fast with Apache Spark with a framework like this. And the journey we are going, of course, as a vendor ourselves, is to add a lot of this functionality in a very easy to use manner for business users to directly just pull sources, pull a data quality operator. Today, you didn't see a data quality operator ready-made in the screen. You do some lightweight coding for that. But consider that if there was a data quality operator just brought into the equation and just you put that in there. Now, that's what you can achieve, and this platform like this and anything that you might build yourself should be extensible to include any developer inputs into the platform and showing up those operators as well into the screen. So we're saying Apache Spark is a great candidate for consolidating data 360 tasks for big data and fast data. It increases your leverage and ROI of your big data lake investment that you've already done, instead of adding more separate silos into your architecture, and thereby you're limiting further costs, and you can take some of that saved cost and put on developing your own modules on top of this, which can be reused in your enterprise. So a visual enterprise-grade Spark platform is a recommended approach, and we, of course, are one vendor that provides that, that's StreamAnalytix. There are other vendors that might provide some pieces of this. For example, some vendors specialize in ingest, some might specialize in analytics. We are a data360 full end-to-end platform on Spark. So with that recap, I'm going to start answering questions now. It's 42 minutes into the webinar, and I think we should start, dealing with some questions that we haven't answered yet. So we've answered a few. I'm going to call out some of that. If you're noticing on the poll, on the chat window, we've answered a few questions already. So, whether somebody asked about StreamSet, somebody might ask about Stream, there are other vendors that we compete with, obviously. The reason why we're saying data360 with Apache Spark is really because there's something special here about StreamAnalytix, particularly because we're doing ingest, enrichment, blending, analytics, and machine learning. We talked about the anomaly detection use case as well today. So that was an example of a real-time machine learning, self-learning algorithm. Similarly, we have built other sophisticated machine learning applications, and both analysts and customers have seen that that's a very, very strong differentiator of StreamAnalytix. Now, let's come to, I think, one question here on what is the multi-vendor integration nightmare on the data360 for customer 360 as an example? So customer 360 is not different from any other big data applications we talked about earlier. For a customer 360 solution, you've got to bring in, again, a data ingest from different platforms, from different data sources. You've got to do deduplication and attributing all of the different silos to one single customer. That's one of the biggest key things that you need to do. You would need to do, again, machine learning analytics to do propensity models. If you are serving a cross-sell, upsell application, if you're serving a churn application, if you're serving customer care application, you would have to integrate those APIs with your customer 360 application. So we're saying by the time you end up building out your customer 360 application, you would end up using multiple product silos, and it may not be convenient to do that, and especially if you're, I think somebody just said you're using Splunk for this. That's great. It may be a very credible way to do it. We're saying you're bringing data into the big data lake anyway. Why would you not build your application layer right on top of this so that that's a convenient one-stop shop? You're building out your application silos on top of your big data platform, and that's what we mean. Let's look at other questions here. Is this tool suitable for unstructured data like tweets? Very much. We can ingest tweets, we can ingest social media data, we can ingest any kind of natural language data as well. We can do sentiment analytics on it, we can do topic classification, clustering on tweets or other unstructured data.
And log data as well, and kind of unstructured logs could also be streamed in.
Unstructured logs can be streamed in, exactly. They're log data as well, right. So the question, one question is, will StreamAnalytix sit as an edge node and can be controlled through Ambari? Yes, there's, first of all, the first part of that question is, we're working with industrial automation vendors right now, and we're putting StreamAnalytix on the edge. We're talking about scenarios where, let's say, there's a camera or there's some scanner or there's some kind of a machine in the plant that needs a quick analytical input, or it sends an input, it takes a model output, and that can be sitting on a 4-node edge computer, 4-core edge machine, a single node 4-core machine, and where you're running a small instance of Spark and StreamAnalytix right there. By the way, StreamAnalytix also supports Storm, and in the future could be supporting Flink as well. We're focusing on Spark on this webinar, but you could have a single node version of this doing edge analytics. So next question, You're saying, I doubt about the technology Spark for streaming applications since it works on micro batches and the supporting for Windows is less, etc. So if there's anything less than 500 milliseconds that you need to turn around, Spark streaming currently may not be an appropriate technology. That's where you would use Spark or Flink. So we agree with that, and that's why we are a multi-engine platform. What are your options for streaming in data from files being dropped on certain locations? And also, do you support the SNMP protocol for ingestion?
Sure. So we have agents right now which can pick up these files and stream them into Kafka from there on into StreamAnalytix on top of Spark. So we have agents which allow you to do that. By agents, I mean the likes of Logstash or Flume, or if you're familiar with any of those technologies, something similar. For SNMP protocol right now, it's not an out-of-the-box operator that we support to read data from. However, we have had a custom implementation of writing into SNMP for one of our customers, and knowing how the SNMP protocol works, if we have to support that as an operator to read, that should be good enough. And again, having said that, the platform is extensible. You can write your own such connectors to read data from SNMP as well, using interfaces that are exposed.
Right. And keep in mind the extensibility of the platform, right? You can add any adapter, like Puneet said. You can add any adapter to receive data, to process data, or to write data out and add it into the StreamAnalytix platform yourself. So those extensibility APIs are provided. What level of cloud integration is available, specifically Azure support, more specifically Azure Data Lake support? We are actually working with multiple customers who are obviously, taking us into Azure and Amazon. There is compatibility with Azure for StreamAnalytix. So we could be installed in Azure in the next version of the product, and right now it can be put on virtual machines on any cloud.
And it does support the Azure Data Lake storage. Next part of the question, we support that. Azure Data Lake.
Azure Data Lake we do support. Okay, great. Could you please say if StreamAnalytix would be a better collaboration tool or pair programming environment for data scientists, engineers, and analysts as an enterprise? That is exactly where we are taking this product. It will be a collaborative environment for business users to author an application and a developer to collaborate, the developer data scientist to collaborate with the business user, and together they can build applications. So the interface you saw today was more of a developer level interface, but we can take it all the way to business user level. That's what's coming up as part of the vision of this product. In what industries you could be able to successfully implement your product? We are seeing our product being applied in financial services, in manufacturing, in retail, telecom, e-commerce, advertising. So we are a horizontal platform that could be applicable to multiple industries. We're seeing a lot of uptake in telco and financial services. At the moment, there's also security SaaS solutions. There's healthcare SaaS solutions that we work with. So it's a horizontal platform that's applicable to any vertical. So is it possible to create Cassandra as a data source in ETL, Azure Data Lake, and everything connected with StreamAnalytix?
Yes, very much possible. We support Cassandra as a data source. You could read data off Cassandra, take that into Spark, do all different kinds of ETL process on top of that, and then finally land it into Azure Data Lake. So very much doable. In order to do this, again, you'd simply open up the canvas, drag drop the appropriate operators, connect them, and configure and deploy it on Spark, and it would do the magic for you. The next question related to this was, can Cassandra database also be used to store all the industrial machines telemetry? Absolutely. Along with Azure Data Lake Store, you can store the output into Cassandra database or even any other database for that matter. Cassandra is an out-of-the-box store for read and write that we support.
In fact, if you're landing telemetry data from industrial machines into Cassandra, what we would recommend is for StreamAnalytix to be before Cassandra, we can directly take the real-time source, do any kind of real-time data processing, pre-processing, and data quality, etc., in real time before you land it into Cassandra. That's also possible. And we are, Apache Cassandra support, DSE Cassandra support comes out of the box with StreamAnalytix. So can you speak to being able to load other models a little more, being able to load a model developed using R? This isn't supported with native Spark capability, so does this tool provide added support for it? Yes. Good news, yes. You can build predictive models with R or SAS or other tools that output PMML, predictive model markup language. So you could build a model in R with a limited data set, export it to R, and we have a library that supports PMML with multiple algorithms. And you could bring the model here, and you could actually scale out the model on Spark using a Java implementation of the same model. And that we support out of the box. That's what we call our PMML adapter. Hope that answered the question. We will engage with you, the person who asked that question separately, because I know you asked for it. We will engage with you on that. Thank you. Comparing this tool with Informatica BDM, do you guys have a native engine or ability to point to a different engine or run mode like Blaze or Hive, etc.? Yes, we are a multi-engine platform, but we are typically using and integrating with open source engines. We started with Storm when we released the first version of this product. We then released Spark Streaming, and we now have released Spark Batch. We are looking at things like Flink as an option for in the future. We see that being requested by various enterprise customers. And Hive is an option for read and write. We don't see Hive as an execution engine. But for batch tasks, if you're looking at batch processing on Spark, we would do it directly on Spark.
Yeah, you could load data from Hive tables. You could do your processing on top of Spark, and then again write your output back into Hive tables. You could also use Hive as part of the Spark SQL as well. So you could write your Spark SQL queries, which could potentially be firing underneath on Hive. So that is one way of using Hive as an engine. Need be.
Debugging and performance tuning on DB issues possible in real time. I'm not sure which DB issues you're talking about. We can do debugging and performance tuning on the Spark pipeline itself in real time. So you can get insight into how your Spark pipeline is performing. If you're talking about loading issues, yes, that's possible. That's scalable. A scale-out mechanism to load HBase or to load issues would be something that you'd probably be interested in. We have, in fact, in a particular customer scenario, they were, for example, if you're doing parallel high-speed loading into HBase, there are challenges with that. We have solved those, and we have created an end-to-end throughput that could take you, to all the way to hundreds of thousands of events per second, all the way from receiving from Kafka into Spark or Storm into Spark, and then loading it into HBase or Elasticsearch or a combination of that, and Solar as well. So yes, we've tested out that kind of scenario, and you could do debugging and performance tuning of that pretty effectively with this platform. Pankaj, Bagzai, over to you as the host of this webinar.
All right, you already stepped over the time limit for today's webinar. We have already asked people to rate their experience from the webinar session today. I've already seen some responses come in. I'm requesting for the people already now present on this session to rate their experience with the webinar on a scale of 5 being the best, and also provide any specific feedback and comments. As something to call off the session, we will be at the Spark Summit and Hadoop Summit in June next month. We hope to see you there. In case you're planning to attend, we'll be glad to see you there. We are exhibiting and sponsoring at both those events. And we also invite you to visit our website and check out more of the product and reach out to us if you have any more questions about the subject. Without further ado, I'll bring the session to our end. Thank you very much for joining us today. We'll keep in touch with you. Thank you very much.